So for this, experiment 3, available chlorine in household bleach. The bleach that we use for killing germs or for decolorization or our toilet cleaner has a toilet cleaner sometimes. Not every toilet cleaner has the bleach, some other thing they have, but bleach is a very strong oxidizing agent that will cause the decolorization and kill the germ instantly. Okay, so the main thing in the bleach is that is the main factor or main agent in the bleach that causes that thing is the chlorine or chloride ion, all right? But chlorine gas is very toxic and it cannot be handled in the household. It has to be handled very carefully in the extreme conditions. So chlorine cannot be used in household, but chlorine is needed to do all those things, to clean up the germs or kill off the germs or clean the rusty things, okay, or a stained bathroom. So that is why this chlorine is used as a hypochlorite ion, okay. So hypochlorous acid, there is a hypochlorous acid, HOCl. There are a few types of chlorous acid actually, chloric, chlorate. So hypochlorous acid, and from there, since that is an acid, the acid is not used because it will be, acid can cause some problems. So sodium hypochlorite, the salt of that acid, is used. So from that sodium hypochlorite, this chlorite ion is coming from the sodium hypochlorite, and this is the main factor that will be needed, or we need to be we need to consider of how good the cleaning process will go. That means the higher the concentration, of course there is a limit, but the higher concentration is better. In that, in a sense that if there is a very high concentration, you can dilute it and use it as per your requirement. In that sense, I'm saying it's better. Not always high is not good. Okay, so when we go to the supermarket or groceries, then we go by bleach. We will see that the weight by volume percent of bleach, okay, is 5% or 7%, sometimes 15%. Depends on the price or manufacturer. So let's say that we go and buy it, how much of the bleach is there in that liquid or in that bottle we will have. So that is we need to find out. But another problem, as I say, that the chloride, hypochlorite ion, and it is sodium hypochlorite, is a salt already. So we cannot titrate that salt unless we liberate the chlorine, okay? So since it is a salt, we cannot titrate. It's not an acid or a base, it's a salt. So what is the idea is that if we liberate this chlorine or chloride, right, liberate this from working today, hang already. Okay, this chloride, OCl, we will liberate or take out the chloride from here, and after that, with the help of something, and after that we will try to find out how much of that compound was needed to liberate that chlorine, right? So here, from the first reaction 1, we see that OCl and then iodide, okay, iodide was used. Oh, hold on, I don't know. It's totally not working. My computer hang. I don't know whether you can hear me. Hello, guys, can you hear me? Anyone can?
Yeah.
Hello?
We can hear you.
Hello? Can you hear me? Hello? Hello. Can anybody hear me?
Yeah, we can hear you.
Okay, thank you. So for almost, I think, 5-7 minutes, they didn't hear me, I guess. I don't know, my computer is hanged already. So, okay, let me show you the files. I so just started. All right. So now we are talking about experiment 3, household bleach, and can you hear? And can you see?
Yes, we can see too.
Hello. Hello. Hello, guys. Can you hear me?
Yes, we can hear you. Yeah.
Okay. Is there any echo? Why do I can hear my own voice? Oh, probably my desktop. Okay, hold on. Hello. Okay, no more echo. Okay, so now all right. So please let me know if you can see the document that I'm showing for experiment 3, analysis of available chlorine in household bleach. So what I was telling, let me start the recording again. Probably I need to record. Okay, recording started. So the thing is, all right, okay. So this household bleach or the bleach, bleach, that is we call the bleach, is actually the main ingredient for bleach is chlorine, right? And of course it produces oxygen as well. But for here, the chlorine that we are interested at is responsible for disinfection and decolorization. It is very strong oxidizing agent. Okay, so how much chlorine is in the solution or in the manufacturers, in that bottle is there, we need to find out. So I think I was talking about that we cannot do this direct titration. Directly you cannot put anything else and then it will be titrated, not like that, it doesn't work like that. So what we have to do is this hypochlorite ion is titrated with or mixed or reacted with iodine, okay, with iodine, with excessive of iodine, so that all the chloride ion will be ion is released or removed from the hypochlorite ions. So here in this case we see that the hypochlorite iodine is moved, iodine is liberated, because iodine here negative charge, that means potassium iodide we added. From there iodine has been produced, and hypochlorite, from hypochlorite ion to chloride ion was produced as well. And it is an acidic medium. So those who already know what is why acidic medium is needed, or and what does the acidic medium means, you can refer to the yesterday class. From there we see that iodine here is iodide ion that is carrying one negatively charged, right? One negative charge. Each of the iodine ion, there are two ions here, so each of them are carrying one negative charge. However, on the right side, that is product side, we see that iodine, this charge is no more, rather the two iodine formed an iodine molecule, all right? And then from here, since it was carrying one negative charge, but here there is no charge, that means it has been reduced, right? Sorry, oxidized. That means the electron has been lost and iodine is oxidized. So in this way we can explain the other ions, what happens to the other ions as well. All right. So by this oxidation reduction reaction, we can find how this the thing changes, or find out the concentration of this just like previous time. Yeah, you will be given this. Hello. Just like previously, you will be given the data, all the data, sodium chloride, hypochlorite, the bleach, concentration of the bleach, and concentration of standard sodium thiosulfate. All those things will be given to you. And this time, please remember to, do this. I mean, fill up this step 3, step 4, step 5. What are the liquid that you should be using for rinsing these following items, graduated people? The liquid that we'll be using is followed, what liquid are you going to use with this apparatus, with this glass apparatus? Okay. Now it will be given. So from here we will find the 3 concordant, and we will take the 2 decimal places. It's not saying about a significant figure, but it says the 2 decimal places. All right. Afterwards we will see that using the concentration of standard sodium thiosulfate, because sodium thiosulfate is given here, right? Sodium thiosulfate, you know that how much of sodium thiosulfate, the concentration of sodium thiosulfate, so you know the number of moles. And this sodium thiosulfate is coming from the burette, so you know the exact number of volume. So from there you find. After that, this bleach, diluted bleach, we are taking into the conical flask. In that conical flask, we are adding a bit sodium, potassium iodide. for the liberation of you know, the chloride from the ion. And then it is, the reaction is happening as per this reaction is shown below, like 1:2, right? Hypochlorite 1, iodine 2. In this form, it will be formed. So from there, we can have a good estimation of how much, or calculation of how much of the iodine will be required for C. But for B, as we are adding 5 milliliter of 1 molar potassium iodide, so from there we can find the number of moles of iodine. All right, so now hypochlorite ions, how much hypochlorite ion will be in the each 20 milliliters, so we can find from this reaction, stoichiometric ratio of the reaction 1:2, and then we can calculate the diluted and undiluted thing. From there, we can find out the mass of sodium hypochlorite should be there, and then the volume by weight percentage. Okay, volume by weight percentage, and volume by weight percentage is the how much of the bleach was taken. Bleach, the mass of the bleach, and the volume of the bleach times 100%. Okay. So in the discussion, you should be talking about the process as well, all right? The process is good, bad, not, what are the other things, good and bad, and is there any other third option? No. Okay, if the process is good, how the process is good, why the process is good, what is the most crucial step in that process, all right? And why, where we should be more, we will be taking more precautions in those whole, how many steps there are, many 10 steps. Which 5 steps, or which 2 steps, or which 1 step is more crucial that will change the, all are special, all are required very much, all the steps requires very much attention. But if, like any of the step that is a little bit changes, then the whole thing will be changed. What is the most crucial step here, that, and what extra caution that we should be taking for that process? All right, and then here, oh, forgot to mention that here we are using starch. Okay, the starch that we actually eat as a, as like food in the starch. Starch in the food, okay? So those things that we eat as a form of food, different type of food, that starch you are using it here for as an indicator, and that indicator usually will be used at the for the equation 2. What is equation 2? Okay, here. So when after we mix this potassium iodide and sulfuric acid, and this thing will be formed in the solution. After this solution, this solution will be started. So you see the second reaction, there is no chlorine or water. That has been totally removed from the equation. We are only now concerned about iodine. So with this iodine, we are adding the thiosulfate, right? And then iodine is being reduced again to iodide ion, and here when the reaction is happening, some process, iodine is brown. Okay, when it is formed, it will be brownish, dark brownish color, and when we are adding this thiosulfate to this brownish color, it will start to fade away, and then pale yellow, and then start to fade away. At that moment, when it becomes very fade, just looks like very clear, almost clear, then we should add the starch, and that starch at the end point only will change the color to blue. So starch is added here as a chemical indicator to know the thing. And how starch is good, why we could not use the other indicators. If you can, I know that you have not learned it, but you can try. Okay. And how much is the, okay, what are the errors? You only, not only that this error, that error, but mention it whether it is under the systematic error or random error. And if it is a systematic or random error, which error can be removed or eliminated by what means, right? That is a measurement that what means we should be doing to minimize that error. Okay, and then, okay, after that you tell that the result was in this form, we found in this form, and afterwards you in the conclusion you say that whether this process is good, okay, whether this process is good to meet or to find out the aim that we aimed for. We aimed for to find out the concentration, whether this process is good, how good it is. If it is not good, what are the other process we can follow instead of this process, right? So these are the things that should be in the conclusion, that you conclude it. That, okay, is good, is fine, it can be done in that way, or it cannot be done in that way, so just don't waste your time, don't do something other process. So that is the conclusion, remember, right? We do it. That is the thing. So for this discussion and conclusion technique will be followed throughout all the resultant discussion that we'll be doing. I mean, all other experiments. Okay, so this is it actually. And do you have any question? Anyone has any question? Okay. No question. Part C and part D. Part C and part D. Where is that? Part C and part D. Okay. Using the equation of the reaction between hypochlorite ion and iodide ion to find the amount in mole of hypochlorous ion. Okay. Hypochlorite ion, sorry. In each 20 milliliter allotment of diluted bleach. For this number 3, it says that each 20 milliliter, because 1, 2, 3, 4, we did the 4th titration. Every step we have taken the conical flask, right? Every step we have taken the conical. I cannot draw because I don't know why it is disabled today suddenly. Okay, so there will be 4 conical flask, and in that conical flask we are taking the bleach, diluted bleach. Okay, so since it is in the diluted bleach, number C is talking about diluted bleach, and in that diluted bleach we have added potassium iodide, 5 milliliter of 1 molar potassium iodide from, you can see that, yeah, step number 6, 5 milliliter of potassium iodide we have added, and also sulfuric acid. So it is saying that 5 milliliter of potassium iodide means how many moles, right? Actually, I am telling you everything. I shouldn't be telling all these things. So 5 milliliter of potassium iodide, how many moles is there? And then according to this reaction, how many moles of the hypochlorite ion could be there, or there, I mean, chloride ion could be there. It's not final yet because we have not done the titration, because the potassium iodide is just added lump sum. Okay, potassium iodide, not lump sum, it is excess. In excess, it was added, so we cannot, I mean, just rely on the number of moles of potassium iodide and say that exact amount of or half of this hypochlorite ion is there. No, we can from here we can say that how many iodine was there, and after this, when it becomes titration is already done. So when the titration will be completed, that means this iodine, okay, this iodine is being titrated. So how much iodine was titrated? From there, I will know that how much iodine I used and how much of hypochlorite ion was there to react with that iodine. Okay, so these three, number C, we have to find out the number of moles of iodine, and then from there, oh my God, what is that? Is it a message? Oh, okay. Okay, so from there we know that how much of the hypochlorite ion is there in the 20 milliliter electrode sub. Ultimately, this is the thing that we want to know, so we will know from that reaction. Calculate the concentration in mole per liter of diluted bleach sample and the undiluted bleach sample. If you know the number of moles, right, of this hypochlorite ion, and it is in 20 milliliter, I hope that you can find out the number of, concentration, that means moles per liter of undiluted bleach. And this, when you find the undiluted bleach, the concentration, we can use the dilution factor to find out the undiluted sample. I hope that answers the question. Brian, sir, what is deduce? Deducing means you discuss it, or you process that thing, and then okay. Oh, so deduce means you process that, you discuss about it, and then from there you funnel it down. All right. So like you discuss it, and then from the discussion you slowly go to the conclusion. So that will be the deducing. You are deducing a formula, you are deducing a theory. First you have to discuss about all those things. So is this also a group? Yes, is that will this is going to be a group assignment as well. Those who are not working in the group, okay, I have heard something from you guys. You don't, if you are not playing in your group part, all right, then I have to, I don't want it, I don't like it, but I will take some measure. Believe me. You think that I will just let you, do whatever you do? You cannot. This is a group assignment. You have to do your part. You have to sit down and divide your work, and then you do your part, and then you send it back, or you take back from your partners, compile it, and then upload. All right. This is very important. If you do not follow this, or if you say that, okay, I don't want to help my group members, then you are in trouble. I don't want to make you scared, but some students never understand until they get punished. So if you want to wait until get punished, up to you. Any other question?